Welcome to my channel. If you have not subscribed my channel, please do it now. Now let's get to the video. In this video, we're going to talk about the weightlessness condition on the earth. We feel our weight because of the normal force we receive from the ground or the chair you are sitting or on the floor you are standing. Because of the normal force, you feel a weight. But if you look at the free body diagram now, let's say, or if you draw all the forces, in fact, there are two forces acting onto you. So what does that mean? That means now let's say if the earth is not spinning at all, then there will be only one force, that is the weight. That weight is the because of the acceleration due to the gravity or the gravity force. But we know that the earth spins about its own axis, so there is an additional force. This additional force is radially outward because we are in a non-inertial frame of reference, and this force we call as a centrifugal force. So we have now two forces. The one force is the weight due to the gravity, and the other is due to the centrifugal force. And the value of centrifugal force is m omega squared cosine theta, and we already have derived this equation. And why r cosine theta? Because if you look at this point P, this moves into a circle here, and the radius of the circle is r, which is r cosine theta. Okay, so that's how we got this centrifugal acceleration. Remember, the formula for the centrifugal acceleration is centrifugal force is m omega squared r, and in this case r is capital R cosine theta. Capital R is the radius of the earth, and theta is this latitude. So this clearly shows that the centrifugal force is the latitude dependent. It will be maximum at the equator and zero at the pole. Okay, so the apparent acceleration or the total acceleration considering the spinning of the earth is given by this equation here. We already have talked about this equation, and in fact I have derived the equation in my other videos. So now if I consider at the equator, so let's find out the value of g prime at the equator. Or if I consider at the equator, the theta would be 0. So if I consider theta equals to 0, I will have g minus omega squared r. So if you think of weightlessness, what does that mean? That means the total acceleration must be exactly equal to 0. So this term must vanish. This term must vanish. If this term vanishes, then your weight, there is no acceleration at all. So let's consider that at a particular value of omega is the angular speed of the earth. At particular angular speed of the earth, this term vanishes, or this term becomes 0. So now if this term is 0, so I will have g minus omega squared or omega squared re. Re is the radius of the earth at the equator, because we are considering at the equator. So omega prime would be g over re. So this is the condition for weightlessness. That's the condition. Okay, so now let's find out the angular speed of the earth for this condition. So g value, we usually plug in 9.8, and radius of the earth is at the equator is this value here, 6371 kilometer. So if you plug in the value, the angular speed of the earth would be 1.24 times 10 to the negative third radian per second. So from this angular speed of the earth, you can also calculate the time period. What does the time period means? The day-night cycle. Okay, and the equation is t prime equals to 2 pi over omega s prime. That's the equation, or that is the relationship between the time period and the angular speed. So you plug in, you get this time period here. And if you calculate in terms of hour, that is the hour you will get 1.41 hour. And this is very interesting now. So it says if the time period of the earth is reduced from 24 hours to 1.41 hours. Right now it is 24 hours. But if the earth starts spinning faster and faster and becomes the time period becomes 1.41 hours, then your weight on the earth would be exactly equal to zero at the equator. And for this to happen, the earth has to spin 17 times the further 17 times faster than its regular angular speed, or it has to spin 17 times faster. If the earth starts spinning, let's say 25 times faster than the regular angular speed, you would fly away from the earth. Okay, but so in summary, let me tell you that if the earth starts spinning with this with a time period of 1.41 hour, your weight on the earth would be equal to zero. For this to happen, the time period of the earth has to go from 24 hours to 1.41 hours. That means the earth has to spin 17 times the faster. If the earth starts spinning more faster, you would fly away from the earth. And you can imagine this. Let's say, for example, you are on a spinning disc and you are standing right here. Let's say you are standing right here. And if this disc spins slowly, then because of the friction, you might not move. And if it spins faster and faster, then you would fly away from these things. That's exactly what would happen on the earth's surface. Okay, but for luckily it is 24 hours and will never fly away, or our weight would never be equal to zero. So this is from this video. If you have any questions, write down in the comment section below, and do not forget to like, share and subscribe the channel. Thank you very much.